Starting 7-1, these are the practice problems here. Normally I do like a concept review before we jump into the practice problems. I'll just do a little review up at the top. This lesson is all about the angles of polygons, so like angles in a shape. We've seen this before, especially the one that we've seen the most often with triangles. Like the angles of a triangle equal 180 degrees, and we know that those three angles of a triangle add up to 180 degrees. But there's also a specific number like this for every shape. So quadrilaterals, all the angles add up to 360, and pentagons has a number, hexagons has a number. But instead of memorizing the specific number for each shape, there's actually an equation. So we're going to make this box up here. And so the theorem actually has to do with the equation. So we're going to have shape, interior on the inside, angle, interior angle, so inside angle, theorem. Polygon interior angle theorem. And this theorem states that the sum of the interior angles, the sum of the interior angles of a polygon is n minus 2 times 180. And n is the number of sides of the shape. So like number of sides of a triangle would be 3. 3 minus 2 would be 1, and 1 times 180 gives us that number. Another thing that will make this a little bit easier is knowing that the number of sides of a polygon equals the number of angles. So we're going to be talking about angle measure. The number of sides and number of angles is the same. So when you're looking at a pentagon, you could either count 5 sides or 5 angles. It's the same number. Okay, then for the practice problems, we're going to practice using this equation. So it says find the sum of the measures of the interior angles of the indicated polygon. So we're going to be using the equation n minus 2 times 180. N is the number of sides. So for number 1, and for these problems, we're going to do number 1 and 3. So you can cross out 2 and 4 if you want to use that space to solve and write a little bit bigger. Okay, so number 1, it says nonagon. A nonagon has 9 sides, so n will equal 9. And then we can plug that 9 into this equation. 9 minus 2 times 180. 7 times 180 is 1,260 degrees. So that means for a nonagon, all the angles add up to 1,260. And then number 3, it says a 16gon. That means 16 sides, so n will equal 16, which we plug into our equation. So plugging that in, we'll get 16 minus 2 times 180, so 14 times 180, and that comes out to 2,520 degrees. So in a 16-sided shape, the angles add up to 2,520. Okay, then the next exercise, using the same equation, it says the sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. Okay, so now what they're doing is they're giving us the sum, so they're giving us this answer, and we have to solve the equation backwards to find n, the number of sides. So the way we will set this up is n minus 2 times 180 equals, in this case, 720 degrees. So we're only going to do 5 and 7, so you can cross out 6 and 8. Okay, so to solve this for the number of sides, we're going to divide both sides by 180 to solve for n. Then I get n minus 2 equals 720 divided by 180 is 4. Then add 2 to both sides. N equals 6. So therefore this shape has 6 sides, and it is a hexagon. Yes.
The first one we did like what did I say? It's not different. We did never mind.
Okay. If you think of it, let me know. Okay, so then for number 7, it gives us the answer. So we're going to use the same equation, n minus 2 times 180, and then just set it equal to 2520. And then solve it backwards for the number of sides. You may notice that this number actually matches what we did here. So this should solve to 16. We can kind of check ourselves that way. But to solve this, we would divide both sides by 180 to cancel that out. N minus 2 equals 2,520 divided by 180 equals 14. Plus 2 on both sides. Yeah, n equals 16. So that'd be 16 sides, 16 gone. Is what that shape would be. Because it says classify it, so I wanted to name it too. Okay, next, for this next section, we're going to do 9, 11, and 13. We're not going to do 10, 12, and 14, so if you need that space, it is available. Okay, so for number 9, it shows a 4-sided shape. It wants to know what x is. So something that would be helpful just to like have memorized is the angles of a quadrilateral add to 360. Angles, specifically interior angles, of a quadrilateral add to 360 degrees. You could calculate that using the equation, but it comes up often enough that if you haven't memorized, it's helpful. Okay, so if angles of a quadrilateral add to 360, and this is a quadrilateral because it has 4 sides, then to find x, we can just do 360 minus these 3 angles to find x. And if you subtract all this, it equals 64. So x equals 64, and that's this angle right here. Right. Number 11 is the same type of problem. It's a quadrilateral. It has 1, 2, 3, 4 sides. Something I like to do to save myself a little bit of work in showing my work is like all these angles add to 360. So I'm going to show 360 minus, and just kind of like circle these numbers. And so like in a calculator, you would just do 360. Oh, this one's dead. You do 360 minus 154 minus 88 minus 29, and then it gives you what's left over. So that equals 89. So x here equals 89 degrees. So instead of having to write all that out, I just showed it that way. Okay, then just kind of drawing a little line because this one's different. This one's not a quadrilateral. It doesn't have 4 sides. We can count how many sides it has. 1, 2, 3, 4, 5, 6 sides. It has 6 sides. So therefore, the sum of these interior angles is going to be a different number, and we don't know what that number is. So we can use this equation, though, to figure out what all these angles add to. So we'll plug in 6 for n. 720 degrees. So all of these angles add to 720. And now that I know that, I can do 720 minus all these numbers in a calculator and just like type it all in, and whatever I get out will be this x, and it comes out to 70 degrees. I said I'm trying to save some brain energy so we don't get too tired. Okay, then on the next page, on this page, we're just going to do one problem. We're going to do number 17. Okay, so for number 17, it says find the measures of angle x and angle y. Looking at this picture, angle x and angle y have this little arc here, meaning that they are the same measure. So that's going to be helpful information to know. And then it has this little square here, so this angle is 90 degrees. Cool. Okay, so where do we go from here? Well, something that would be helpful to solve this is knowing what all these angles add to, like what the sum of all these angles are. And we can use the equation n minus 2 times 180. And since this has 1, 2, 3, 4, 5 sides, we plug in 5 to solve this. And 3 times 180 is 540 degrees. So all of these angles add up to 540. And so we can do 540 minus these three angles. And when you plug that in a calculator, it comes out to 184 degrees left over. And then that 184 needs to be split evenly among these two angles because they're equal. So we do 184 divided by 2 to get each of those angles, and it comes out to 92 degrees. So x equals 92 degrees and y equals 92 degrees.
And then the Taylor's three times that it equals 85.
Yeah. Okay. On the lower part of this page right here, there is an additional type of problem that comes up on the homework that I want to go over. And on the homework, it says, okay, each angle of a regular polygon equals 160 degrees. How many sides does it have? I abbreviated that a lot. And this is the exact problem that you could get on your homework. So to find this out, if we do 160 times the number of angles, that would be the sum of all the angles in the polygon, right? And then we can put that equal to the equation for the sum of all the angles in the polygon and solve for n. So saying each angle is 160, and so multiplying that by each angle would give you the sum of all of them, and that would equal the sum of all the angles. So then from here, we would distribute the 180. Going to get this over here. Divide by negative 20. And n equals 36 divided by 2 is 18. So 18 sides. So that's how you do it. So if you get that one, that's the actual answer. Or if you get something similar, that's the process. Okay, one more page. So we did all the hard stuff. The next part's easy. Okay. I know I'm pushing you guys a little bit, but that's what I'm supposed to do as a teacher, is to push you a little bit further than we've gone before. Okay, so then over on this page, we have polygons again, we have shapes, but notice how they are different. This time the angle measures are all on the outside of the shapes. These are exterior angles. So what they did was they extended the sides of the polygon to get these exterior angles. And the theorem for this is exterior angle theorem. Like I said, this one is easier than what we've done actually, so don't stress. Interior angle theorem says that the exterior angles of all polygons, convex polygons, add to 360 degrees. So you don't have to calculate a different number for different shapes because all convex polygons, the exterior angles add to 360. Okay, so how are we going to use this information? We're going to do 21, 23, 25, 29, and then the rest you can use like the space if you need to. Okay, so how are we going to use this information? Well, to find x here, all these angles, the exterior angles, add to 360. So we can do 360 minus these numbers, and it equals 111. So x equals 111 degrees. Great, and then 23. Here, again, all the exterior angles add to 360. This one's a little bit different because it has 2x and 3x here, and it wants to know x. So we can just set up an equation, 2x plus 3x plus 71 plus 85 plus 44 equals 360 degrees to find x.
Just now we're using an equation.
Yes, I mean, technically you can use the equations for the other ones. I just thought it was easier to plug it in a calculator. But yeah, all the angles add up to 360, and then I'm going to combine like terms here. I get 5x, and then combining these terms, 71 plus 85 plus 44 comes out to 200. Five x equals 160. X equals 32 degrees. Oh wait, not 32 degrees, it's just 32. And then 25, remember we're only doing number 25, so if you need to use this space, you can. It says, find the measure of each interior angle and each exterior angle of the indicated regular polygon. Regular polygon means that all these sides and angles are the same. So like they're all equal, which is important information. For a pentagon, has 5 sides. So we're going to find each interior angle. So label this so that way when you're doing the homework, you'll know which process to follow, and then each exterior angle. Okay, so for 5 sides, interior is n minus 2 times 180 to find all of them. We plug in 5. And that comes out to 540 degrees. But again, that's for all of the angles of that polygon, and it wants each of the angles up here, so each. So then we have to take 540 divided by 5 to get each angle. So then 540 divided by 5 is 108 degrees, degrees for each angle. For each angle, specifically interior. And then exterior is always easier. 360 degrees is what all the exterior angles would equal. Divide by 5 angles, and it's 72 degrees for each exterior angle. One more. We're almost done for real. Okay, 29. It says modeling real life. Octagon towers is an octagon-shaped condominium building, so 8 sides. In Miami, Florida. Assuming the base of the octagon towers is a regular octagon, meaning all the angles are the same. Find the measure of each interior angle at the base of the octagon towers. Okay, so first we need to find what all the angles added up equals. So n minus 2 times 180, you do 8 minus 2. 6 times 180 is 1080. That's for all of the angles. Oh, sorry, there you go. All the angles. Then to find each angle, we do 1080 divided by 8. And that number comes out to 135 degrees. And that's each angle, each interior angle of that octagon. Okay, that is all. You have the last 15 minutes to do your homework, so grab a laptop, get logged in. Good job today. I know that was like a hard workout.